All right. Do you have any updates on Casper?
Yep. Um, so yeah, there's quite a bit actually. So since last week, okay. So um, we've been working on um, migrating off the block store where we can. Just for a bit of background, the block store is what keeps the full blocks, including the body, and we have a separate type of store called the block DAG store, where we just keep the headers of the blocks and how they're related to each other, and how it, as in like how it forms the DAG. So we've been going through each validate function and removing any usages of block store where we can, and replacing them with calls to the block DAG store, which are lighter. And so we've done that for the justification regression, validation, the block number, and the sequence number. So besides that, we've made the estimator return block hashes instead of a full block. So a similar idea there, where we're removing sort of unnecessary queries to the block store. And we've also made a check to limit the deploy history duplication check depth. And so what that means is that currently what we do is, so to prevent replay attacks, we can't allow we can't allow a transaction that has gone onto the chain to be inserted again in a different block. Because if that was allowed, then people would be able to execute what's called a replay attack. And that basically means that they can do the same thing as the transaction that went in first. And so, like, unless you had some kind of idempotent scheme underneath, that becomes an attack vector. So the solution to that is, well, you just prevent duplicate transactions. Except this could be costly, because one naive way to do it, or the way we did it previously, was that we would check the entire DAG to see whether there was or like the same transaction that we're about to place into the about to be proposed block. And if there was, we would mark the current transaction as a duplicate, and we would not include it in the block. And so the update to this is that we add a field in the transaction. I called it validate after block number. But basically the idea is you can only insert the transaction after the block number corresponding to that valid after block number field value. And so what that means is there is a lower bound to which block that transaction can get inserted in. And there's also an upper bound where you set a arbitrary expiration threshold. And so currently I just put it as a constant of 50 blocks that can be adjusted. But anyways, the idea is if there is a transaction and its valid after block number is 50 greater or the current block is more than 50 greater than the valid after block number value, then we say, oh, this transaction is expired because the block tag got too far, and we want to like fix the range in which the transaction is valid within the block tag. And so now we have this range. So what that means is every time we do this validation check to see whether there's no duplicate transactions and therefore replay attack possibilities, we only have to check that range of 50 blocks from the current tip. And so yeah, that should be our last place where we were previously traversing the whole bag. So now Casper is fully independent of or let's put it this way: if the estimator doesn't have to traverse the whole block because the so-called lowest common ancestor is above the genesis block, then that is our maximal traversal. So yeah, we should get a pretty large performance boost there.
Oh, good. That's good. I mean, I didn't hear anything that sounded untoward. So, how do you guarantee the consistency between the two stores?
The block store is just a key value store from block hashes to blocks. So yeah, it's just that. And then so the block tag store is the headers only. And so there's no, the block tag store should always have a subset of the block store. And so in some sense that means that there isn't a one-to-one mapping between the block tag store and the block store, because there could be, you can insert arbitrary blocks into the block store that, you know, maybe even come from a different blockchain, right?
Yeah, of course.
And that would be fine.
Yeah, but
because
I guess the point is that they still have to remain consistent, even though one is a subset of a view of the information. It's that the view has to be consistent with the raw data in some sense.
Well, so the only consistency we need is the fact that if there is a header in the block tag store, then that must be fetchable from the block store.
Yeah.
Yep.
Yeah, correct. Cool. So that was one thing. You said there were multiple things, right?
Yeah. So yeah, that's. I mean, I went through 4 things, I believe. The estimator, the duplication check,
okay. Got it.
limiting, and then the validation checks.
Okay. Understood. Good. That's awesome. That's really cool. Well, I was hoping Aditya would come today, but you know, last time he seemed to get what I was talking about with the error correcting codes. But he's not here today.
Yeah. Did you want to talk about them, or?
Well, I mean, I sort of I spoke to what's going on there, right? So what's going on is that they have a so the essence of the argument is that there are certain kinds of conditions that provably terminate, where a condition is essentially a set of input vectors um, around or related to a particular input vector.
Sure. I think you talked about that last time, but
Yeah,
oh yeah,
exactly.
yeah. I guess the questions I had remaining were, or the one we left off last time was like I understand how you could constrain an input set of bits, but like how do you like what
Oh
is
yeah,
the
yeah. That's right.
panning
That's
distance
right. Yeah,
equivalence on the blockchain?
that's right.
Yes.
You and Vlad did not quite understand the relationship between higher data and that you could shift back and forth between more structured data and less structured data in terms of additional communication events.
Yeah, I think I mean, or well, like I think I understand that, but I don't quite see how it relates to the blockchain. So maybe I don't understand it.
Um, well, I mean, how it relates is that uh, you um, so there are two levels. Number one, you have this you have a kind of not continuity. I'm trying to think of the word for what it is. Um, I'll call it continuity, but that's not quite right. So you have a constraint that you might impose that all such higher level expressiveness has to be compilable down to your base level plus certain kinds of communication events, right? And even in the framework of error correcting codes, this is not necessarily the only kind of constraint you might want to impose. So, like for example, in the paper, they suggest wormholes, which are effectively synchronous channels. So what they are able to show is that you can add certain numbers of synchronous channels um, to get different bounds on the termination. So if you compile your higher level data down to just asynchronous communications, you and you say that all such has to be done in terms of asynchronous communications, then you'll get certain kinds of then you'll turn this into only um, uh, just the use of the error correcting codes on the lowest level bit level representation. However, you could, and this is the point I was making last time about the mixed summation fragments of the process calculi. You could compile it down to communications that involve these synchronous channels. So in that case, you don't have the same kind of continuity, right? Jumping up in the structure of the data also involves jumping up in terms of the structure of your communication primitives, or the expressiveness of your communication primitives. That's a lot to take in. So let me stop there and see if that makes sense.
So I mean, I guess, is it like I think I follow the argument, but I feel like I'm walking down this path that I don't see the goal to, if that makes sense. Like, let me put it differently. So
The goal.
the
So here's the
standard
goal. The goal
consensus.
is I can get to the goal, right? The goal is I want a language. I don't want to impose one particular set of synchronization constraints. I want a language-based approach in which I can say, you know, any synchronization constraints that have this kind of shape, and I need a specific way of describing shapes. So that's it. And then the error correcting codes provide me a way of describing shapes. So like I know exactly what constitutes an error correcting code when someone has given me one that's well specified for a particular data type. And I know what the corresponding synchrony or termination guarantees are. That's it. That's my goal. So that I don't say round robin, that's it. That's my only strategy. I want you to be able to say to me, here's my strategy, and you deliver a specification of your strategy. And so I need a language for you to deliver to me a specification of your strategy. Does that make sense?
Sure. Do you think it's possible to, I guess, work on, I guess, describe an example, if that makes sense? So the one I was thinking about is, let's say you have a set of bits, um, and we just want any strategy that picks one bit out of that set, and all the validators have to agree upon it, or all the processes. Like I guess it's a pretty
Yeah,
standard.
that one is given in the paper, right? So I don't have to give that one. That's actually in
Sure.
the paper.
Yeah. So yeah, like so then the next, I guess the next one is, if you have a set of all possible blockchains, like how do you make it so that, or sorry, yeah, like the inputs are the set of all possible blockchains, and the consensus output you want to get is one particular blockchain.
So one thing that you can do is that you can, and that was my point about higher level data. So there are a couple of different approaches here, right? But the simple one is you treat the blockchain itself as your value. It's your space of values. And then you run this consensus approach on that state of set of values. All right, so chains become your input vectors.
Yeah, I guess the difficulty is you can't just like the way you come to consensus is through growing to a specific chain, not you're just swapping between alternative chains.
Right, and that's
If
why I
that
said.
makes sense.
So I was trying to give you sort of, a step-by-step argument, right? So
Mhm.
the first level is like you know, um, you're trying to decide a particular input vector, which would be between two different options of a chain at a particular height, right? So that's essentially the way to compare them. But the better way to do this is to integrate it at a lower level into the protocol, right? Where essentially um, you're adding constraints. Oh. You're adding constraints onto the sorry. Sorry about that. Someone was trying to get a hold of me. Can you still hear me? Can you still hear me?
Yep. Sorry, I was muted.
Oh, yeah, no worries. So you're adding additional tests onto the communications that are happening in the Casper protocol. So effectively, we're constraining the Casper protocol, right? So now we're composing the protocol mechanisms. So we think of Casper as effectively the safety part of it. And now we want to impose something that gives us the additional liveness. And so that's the so there we're imposing constraints on input vectors that are related to the way that validators are communicating blocks with each other. Right? So that's the so think of the block communications as now providing your input vectors.
So, sorry, I guess are we under the model where the input vector is what you choose your final consensus value from, right?
Yeah. Now
Okay.
remember that there's a their framework is more general. So if you go back to the top of the paper, the one I sent out, the sort of interactive consistency, right, which requires that no two different vectors are decided. A process that is an error is effectively the winning process, right? And any decided vector only has values, proposed values from non-errored or non-crashed validators. All right, so it's a little bit different than the Byzantine, right? So the Byzantine has no two different values are decided by correct processes. If a value is decided, it's got to be from a process that's correct. And if all proposed values are the same, then the value decided is by a correct process is that value, right? So that's the. So you have to be a little bit careful about. So what you can do is you can always get Byzantine agreement from interactive consistency. But the interactive consistency is a little bit more subtle.
Sure. Yeah. It's sort of like the like Vlad's approach to his, I guess, initial approach to sharding, right? Where like you say like to it, I should say, you're if you're on a parent shard, then your child shard, if your wait a minute, sorry, if your parent shard, wow, I can't believe this is hard to phrase. If your child shard decides on a block, then your if your parent shard decides on a block, then your shard has to decide on the block is the straightforward approach. But you can say like if your parent shard as long as your child shard doesn't decide on that block, then it must be the case that your parent shard doesn't decide on that block. No, that doesn't sound right either. Sorry,
No, that's
I'm
not
trying
correct.
to make a comparison here, but yeah, like um, yeah, sorry, but yeah, I think I understand, and so like if you have so in some sense it's okay to be, how should I say it, not almost decided on two different vectors, but I guess you you're deciding upon a range, right? Like and as long as like the range is overlapping, it's you're still in um, agreement according to the interactive consistency.
Um, no, you're not deciding on a range, right? That's that again. That's the um, no two different vectors are decided.
Sure. Yeah, we can keep it that way. The definition is as simple as it gets. I was
Yeah.
trying to somehow phrase it into my own words, but
No,
it's pretty precise. Yeah.
I wanted to double check with you. Like the thing that I'm having trouble with the sharding proposal that Vlad has is that I think there are two levels to it for me. One is he's assuming a trust model where the parent and child don't spoof each other with respect to the transition of the virtual machine.
Sure.
So that to me seems to be like like in the wild, that's a really dangerous assumption, right?
Well, I think the assumption is also that if you're on the child, you're in the parent.
If you're validating on the child, you're validating in the parent.
Well, at least that was his
So
initial
basically,
starting model.
everybody's validating all the way up to the top.
Yeah, and so in that
So
sense,
it's
it's
not much of a win from a sharding point of view.
sure. I don't know of his latest models though. I don't know if it changed or anything, but yeah, I agree. If we're still under that model, you're
Okay.
yeah.
Yeah.
You're still winning in the sense that like for the transactions that are local to the child shard, they're not processed by any other um, shards validators.
Local. Right. They're completely scoped within that namespace.
Yeah. But yeah. Anyways, so back to the error correcting codes.
Yeah.
So like so yeah. So you have an input vector that's the values that you want to gain consensus over, and
And
the
what we're insisting basically is that the range of values, the sort of um, penumbra around the agreement can't be a certain distance, or has to be a certain distance, is a better way to say it. And that in other words, you can describe and that distance is described by the error correcting code. Like there's a way of constructing a Hamming distance, or a Hamming ball around that thing, and that ball is described by an error correcting code. Because the error correcting code basically says it constrains all the changes that you could make to those values and still get agreement within a limited amount of time, in inverted commas, where time basically is equal to synchronization events.
yeah, I guess like so my hypothesis, this is kind of what I'm having trouble, but like my hypothesis is that we're going to have to somehow constrain the output of the estimator so that you get the output of the estimator makes this, I guess, yeah, like you have to constrain the estimator somehow to ensure that your input vector doesn't get too far from the other ones.
That's right. That's it exactly.
But I guess, yeah, like, yeah, I'm having a hard time how to, like, I guess I'm not quite even sure how to start on it, if that makes sense. Like, they're like, I just have this kind of visual image or intuition about how these convergences could happen, but yeah,
Okay.
yeah, I'll leave it at that.
So you would like me to write it up, basically write up a toy example for you.
Sure. Yeah. That.
Cool. Okay, I can certainly do that. That's not a problem. That's not a problem. I just, I was hoping a DT would come and we could kind of all get on the same page about it.
I see.
Yeah. Cool. But I can certainly write that up. And but like for me, I always work on the level of intuition, because I find that if I can jumpstart people's intuitions, then I can it's much easier to have the formalism make sense. If I start from the formalism, it ends up being a bit of a wall for people.
Yeah, I could see that.
Yeah. Cool. All right. Well, that's all I've got. Sounds like we had some really good progress on the block store stuff. So I think we can call it for today, unless there's anything else.
Nope. Yeah. So, yeah, hopefully my personal goal here is, like, I want to see 10K blocks on our testnet. That's kind of or at least my personal threshold for this sprint.
That is awesome. That's a great goal. Really good.
Yeah. So yeah, so this is specifically like on short fast. That's the name of the. It's basically like a toy Roland contract, and with 5 validators. So yeah, that's the goal we're heading for.
Sweet. That's nice and crisp. I love it. Very good. Okay. Well, I will. I guess I'll see you at stand up in a little while.
Yep. See you then.
All right, ciao.